Yes. Yeah, good afternoon. So before I start, can anyone please confirm whether my voice is clear? Right. So in the last class, I was briefing you, right? These are the Hadoop ecosystem components I'll be discussing. HDFS, MapReduce, Hive, Scoop, NoSQL, HBase, Kafka, Zookeeper, Rion, and PySpark. So today I'll be briefing you how exactly the data storage and processing is going to happen. How exactly in processing in Hadoop. How exactly the data storage and processing in Hadoop. In Hadoop, data is stored in the form of files. Data is stored in the form of files. Data is stored in the form of files. Each file is again subdivided into smaller parts. See, data is stored in the form of files. Each file is again subdivided into smaller parts called blocks. Default block size. Default block size. See, previously it was 64 MB. Currently it is the latest versions. It is taking 128 MB, 128 MB as the previously it was 64 MB. Now it is taking 128 MB as the default block size. For example, I've got a file f1.txt file. The size of this file f1.txt file, the size is 200 MB. Assume the 200 MB is the file size. It's consisting of some banking data. So consisting of some banking data. Yes. f1.txt size equal to 200 MB, consisting of some banking data. Assume default block size. Assume default block size equal to means the file is divided into fixed size chunks. We call it as blocks. Default block size 64 MB. Into how many blocks, number of blocks, into how many blocks the file is divided. Means default block size. File size by default block size. File size by default block size. File size by default block size. File size is what? 200 by default block size is 64. Means how many blocks? 4 blocks. 4 blocks means, yeah. Observe these 4 blocks. B1 block. Observe this B1 block. Stored within the slave 1. B1 block of 64 MB. Stored in S1. Slave 1. B2 block. B2 block. 64 MB. stored in slave 2. Means 4 blocks are stored across 4 slaves. 4 blocks B1, B2, B3. Yes, B3 is there, right? Again 64 MB. Stored across slave 3. B4 block. Yes, B4 is there, right? 64 MB. Again, sorry, it's not 64. What is that? What is the B4? Right, today I want the sessions to be interactive. What is the B4 size? 8 MB, right? 8 MB. Here 56 MB free. 56 MB free in this B4. It is stored in slave 4. It is stored in slave 4, right? Yes, it is stored in the slave 4. 4 blocks are stored across 4 slaves. 4 blocks are stored across 4 slaves. B1, B2, B3, B4, they are stored across S1, S2, S3, S4. What was that? So in Hadoop, data is stored in the form of files. Files again subdivided into blocks. Default block size 64 in the previous versions. In the latest versions, 128 MB. If I'm taking a file size 200 MB of banking data, assume default block size 64 MB. Into how many blocks it is divided means the file size by default block size, 4 blocks. The 4 blocks distributed across 4 slaves and are executed parallelly. Okay, this is fine. If I'm taking okay, now just observe this. I'm copying the same thing. I'm copying the same, pasting here. f2.txt, this time file2.txt. Size 192 MB. 192 MB. Assume it is 192 MB. This is telecom data. You have got some telecom data in this, right? Okay. Default blocks are 64 MB. Number of blocks, file size by default block size. But 192 by 64, how many blocks? 192 by 64. Exactly 3 blocks. Exactly 3 blocks. Here B5, B5 in system 5, B6 in system 6, B7 in system 7, B7 in system 7. This is not required. This block is not available. Okay. Here you might be getting a query. So here, yes, you might be getting a query. Here, okay. Question is, $56 MB is free. 56 MB is free in B4 block. In B4 block. Why B5 data? Why B5 data is not stored in B4? Why it's not stored in B4? Okay, just 1 second. $56 MB is free in B4. Why B5 data is not stored in B4? Assume B5 data stored in B4. For example, I want to retrieve f1.txt file. Retrieving f1.txt file. Retrieving f1.txt file, right? Yes. Means b1 plus b1 plus b2 plus b3 plus b4, b1 plus b2 plus b3 plus b4. Retrieving f1.txt. Okay, that's fine. Assume b5 data stored in b4. b5 data stored in b4, right? Okay. 64 plus 64 plus 64 plus 8 plus 56. Totally how much? 256 MB. But actual file size is 200 MB. But the actual file size is 200 MB. Wrong computation. But actual file size is 200 MB. Wrong computation. So what are the design principles you need to follow? What are the design principles? Design principles with respect to HDFS blocks, Hadoop distributed file system blocks. What are the design principles you need to follow? Means every file should have dedicated number of blocks. Every file should have dedicated number of blocks. Every file should have its own number of blocks. In a single block, no two files data to be stored. In a single block, no two files data to be stored. In a single block, no two files data to be stored. So in a B4 block, no two files, file 1 and file 2 data to be stored. Means third one, right? All the blocks will have equal volume. All the blocks will have equal volume except the last block. All the blocks will have equal volume except the last block. Except the last block, right? So in the file 1 only it will have 8 MB, right? Yes. Means default block size it is given, right? But even we can increase or decrease the block size. We can configure the block size. We can configure. So we can increase or decrease the block size. How to configure, how to increase or decrease the block size, I'll discuss. But before that, if you see, I'm going to discuss 3 cases. Now you can understand easily, right? How exactly the data storage and processing is going to happen within the Hadoop. Hadoop follows master-slave architecture. One second there. Single master, multiple nodes. Single master and multiple nodes. 1 second. Okay. Single master and multiple slaves. So Hadoop follows master slave architecture in that only one will be acting as the master and all the remaining as the slave nodes are the worker nodes. Next, okay. I'm going to discuss 3 cases now. 1 second. Observe this. Case 1. If the number of blocks is equal to the number of blocks is equal to the number of slaves, means the slave systems. For example, 3 blocks, 3 slaves. Otherwise, 4 blocks, 4 slaves. Assume B1, B2, B3, B4. How many slaves? 4. S1, S2, S3, S4, right? Yes, just a second. Okay. Number of, okay. Blocks equal to number of slaves. In Hadoop, the file divided into blocks. The blocks are distributed across multiple systems. Assume if you have got 4 blocks, 4 slaves, means number of blocks equal to number of slaves, then you will get high speed. You will be seeing high speed. Full parallelism. What you are going to see? Full parallelism. F1.txt. Assume the size is 200 MB. Default block size. 64 MB. Default block size 64 MB. How many blocks? Number of blocks? 200 by 64. Means the file is divided into fixed size blocks. Each block of size 64. I have to say that it is 240. 240 by 64. 4 blocks. 4 blocks. How these blocks are going to be stored across this cluster? This single, these are multiple. S1, okay. Assume that I got multiple. Think that I got 4 systems. S2, S3, S4. B1 block stored here, B2 stored here, B3 stored here, and B4 stored here. 4 blocks stored across 4 slaves. 4 blocks are stored across four slaves, right? Yes. Means how many blocks, the blocks are going to get distributed across the available systems. Here 4 systems available, only 4 blocks. So the number of blocks equal to number of slaves. Fine. So here within the master node, this is the master, within the master node, we have got a service called name node. Name node is available. Name node maintains the metadata information. Metadata means data about data. It won't store the actual data, but the metadata information. First, for example, f1.txt file divided into how many blocks? B1, B2, B3, B4. How many blocks? 4 blocks. B1 stored where? In S1, B2 in S2, B3 in S3, B4 in S4. In which system? Each how many blocks? And each block stored in which system? All this information should be available within the name node that is present within the master node. Okay. This is how exactly the data storage is happening. File divided into blocks. The means everything happens. It takes care by the framework itself. We are not going to do anything here. When just the file, what is the name of the file and what is the block size that you need to specify. That's it. Automatically it is going to divide the file into that block size that you are provided. And it is going to divide that file into blocks. It is going to store that blocks across multiple slave systems automatically. Now, data processing. Data processing means your job is to process f1.txt. Job to process f1.txt. Job should be divided into tasks. Into how many tasks? If it is divided into tasks, then only you can see parallel processing. The tasks can be executed parallelly. Number of tasks. Number of unique blocks. I'm saying the word unique. I'll say why. Not in this current example. In the later example, I'll say why we are using the word unique. Unique blocks, how many? 4 blocks. 4 blocks, right? 4 blocks means 4 tasks. T1, T2, T3 tasks. Job to process f1.txt. Job to process f1.txt into 4 tasks. T1, T2, T3, T4. T1 for executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. Now try to answer the T1 task. So assume 40 lakh records are there. 10 lakh records in this, 10 lakh records in this, 10 lakh records in this, 10 lakh records in this. They are processed parallelly, right? Multiple systems. Who should execute this T1 task? Who has to execute this B1? That is T1 task is for executing B1. For executing B1. Who has to execute this B1 10 lakh records? System 1. S1, right? System 1 only. There is no other choice. Other systems cannot execute this B1 10 lakh records. Who should execute this T2 task? Who has to execute this T2? Which system?
Slave 2.
Slave 2, right? There is no other choice. T3 by S3. T4 by S4. Means if I give a labor example, I'm giving 4 tasks to 4 students. Student 1 from mathematical background. Student 2 from physics background. Student 3 from chemistry background. Student 4 from biology background. If any task related to mathematics, to whom I need to talk? If any task related to mathematics, to whom I need to assign? Student 1 only, right? No other choice. Task 1 related to mathematics, to whom I need to assign? If any task related to the second task related to biology, to whom I need to assign? Which student I need to assign? Try to respond. Unmute yourself and try to respond, everyone. If
Student
any
4.
student 4, right? If any task related to biology, I need to assign to this. If any task related to chemistry, I need to assign to student 3. If any task related to physics, I need to assign to. In this way, same way, if task 1 is related to executing B1, means who should execute S1 only. And T2 task is for executing B2, who has to execute? System 2. T3 task for executing B3, who has to execute S3. T4, okay, in this way, right? Yes. So here, 4 tasks, T1, T2, T3, T4 are executed parallelly. 4 tasks are executed parallel. 4 tasks are executed parallelly by 4 slaves. 4 tasks are executed parallelly by 4 slaves. None of the task is in the waiting state, right? All that are executed parallelly. None of the task is in the waiting state. So that's why very high speed you are going to see here. High speed, full parallelism we can see. Observe this case too. Observe this case too, right? 1 second. One second. Yes. This time observe this case too. Previously, number of blocks equal to number of slaves, but here number of blocks greater than number of blocks greater than number of slaves. Four blocks, 2 slaves. Number of blocks greater than number of slaves.
Sir, this is Srikanth. Hello.
Yes.
Sir, I have a question here. So these slaves, do we determine how they are going to be formed, or there is auto scaling which will be done based on the file size, sir?
See, okay. Dep- Depending upon the incoming, depending on the incoming, right? incoming data, depending on the incoming data. So we are just going to say what should be our cluster capacity. What should be the cluster capacity we are going to decide, right? So 40 node cluster, 60 node cluster in this way. But in the cloud side, we'll be seeing, right, auto scaling feature. Okay.
Okay.
So here number of slaves means your data is going to be stored across the slaves. So if your data increased, if your branches increased, if your customers are increased, you need to increase the slaves also, right? So generally, you see in on-premises, right? You go to the
Right.
in the on-premises, we will say commissioning and decommissioning, adding and removing. We'll add some whenever required, we'll be adding, otherwise the decommissioning means we'll be removing.
Uh,
Okay. Number of blocks, number of slaves. 4 blocks, number of slaves 2. B1, B2, B3, B4. Only 2 slaves. S1, S1 and S2. Assume you have got 2 slaves. Assume you have maintained only 2 slaves. Means here in our example, I'm saying to here what happens, less speed. F1.txt, file1.txt. Assume the size of the file is 230 MB. Default block size 64 MB. Into how many blocks? Number of blocks. Number of blocks equal to 230 by 64. 4 blocks. 4 blocks means here master, slave, single master and multiple slave. Only 2 slaves I say. Only 2 slaves, S1, S2. Assume you have got less number of slaves. Means here B1 here, B2. Here B3, here B4. 4 blocks stored across 2 slaves. Here name node maintains metadata f1.txt divided into 4 blocks. B1, B2, B3, B4, B1 in S1, B2 in S2, B3 in S1, B4 in S2. This is how the storage happens, right? If you got less slaves. Okay. Your job is to process f1.txt, f1.txt. Okay. Always the job is divided into tasks. Into how many tasks means it always depends on number of unique blocks. How many unique blocks here? 4 unique blocks means 4 tasks. Job to process f1.txt. Job to process f1.txt is divided into 4 tasks. Can you see here 4? T1, T2, T3, T4. Yes. T1, T2, T3, T4. Okay. T1 task. T1 task for executing a B1. T1 task for executing a B1. T2, T3 for executing B3. T4 for executing B4. Okay. T1 for executing B1, T2 for executing B2, T3 for executing B3, T2 for executing B4, right? Yes. Who should execute this T1 task? Who has to execute this T1 task?
S1,
S1. T2 task?
S2,
T3 task?
S1, S1, sir.
T4 by S2. Means if you observe here, S1, S2. S1 executing how many tasks? S1 executing how many tasks? T1 and T3. S2 executing how many? T2, T4. T1, okay, T1 T3 by S1, T2. But means in the system one or slave one, when T1 is executing, T3 will be in the waiting state. When T2 is executing, T4 will be in the waiting state. Okay. T1 executing in the system 1, T2 executing in system 2. But if you observe here, only 2 tasks are executed among 4 tasks. Only 2 tasks are executed parallelly. Two remaining 2 are in the waiting state. Previously, 4 tasks executed by 4 systems, full parallelism, high speed. But here, only 2 are executing. Other remaining 2 are in the waiting state. Okay. Only 2 tasks are in the executed, remaining 2 are in the waiting state. So that's why less speed I'm saying. After executing the first T1, T2 tasks, next T3, T4 will be executed parallelly. Okay. This case student. So if less slaves, less speed. If more slaves, more speed. For example, in the case 3, assume you got only one slave. Case 3. More blocks, only one slave. More blocks, only one slave. For example, B1, B2, 4 blocks, you think. Only one slave S1. What are the 4 blocks? B1, B2, B3, B4. Only one slave is S1. B1, B2, B3, B4. This is S1. 4 blocks, only one slave S1. Okay. Means this is your master, this is your slave. Means only one slave. Means all your B1, all your block, B1 block, B2 block, B3 block, all the blocks stored in the single slave. Here f1.txt. If you are maintaining, if it is divided into 4 blocks, B1, B2, B3, B4, B1, B2, B3, B4, B1 in S1 only, B2 in S1, B3 in S1, B4 in S1. This is how exactly the data storage. Okay. Now data processing. In this data processing, okay, job to process f1.txt, f1.txt into how many tasks? Number of tasks always depends on number of unique blocks. How many unique blocks? How many unique blocks here? 4 blocks, B1, B2, B3, B4. 4 blocks means 4 tasks. 4 tasks, T1, T2, T3, T4. Who should execute all these 4 tasks? All these 4 tasks has to be executed by S1 only. S1 only, sequentially. sequentially one after the another. If more slaves, more speed. If less slaves, less speed. If only one slave, right? If only one slave, no parallel processing at all. Sequentially, it is going to execute. Okay. So here, case 1, case 2, case 3. Case 1, 4 tasks, 4 slaves, each task taking 1 hour. Total time taken to execute all the 4 tasks. Everyone, try to answer.
1 hour.
1 hour it takes, right? Now observe this. What is the case of the case 3 if it is not parallel processing? Case 3 is not parallel processing, it is sequential execution. Sequence, for example, very simple logic. For a building construction, if you have got 10 tasks, 10 tasks is given to the 10 laborers, they will be working parallelly and complete it. But tasks are 10, only 5 laborers are there. Each one has to execute two tasks. First, they will be executing the first tasks, first 5. The remaining 5 will be the waiting state. So in the case 2, observe, try to say me that total time taken. 4 tasks, but only 2 slaves.
2 hours.
2 hours, right? Takes 1 hour. Because first in the first hour, they'll be executing the first 2. The second hour, they'll be executing the remaining. Case 3, 4 tasks, but only 1 slave. Total time taken.
4 hours.
4 hours, right? Means what is your observation? If more slaves, more speed. If less slaves, less speed. If no only one slave takes sequentially, it is going to execute. Okay, fine. Now 4 cases we have discussed, right? So more the slaves, more the speed. Okay. Now I'll go back to this case 1. I'll go back to this case 1, right? So in case 1, number of blocks equal to number of slaves. 4 blocks, 4 tasks. T1 task here, T2 task here, T3, T4. T1 task for executing this 10 lakh, B1 10 lakh records. T2 task for executing this B2 10 lakh records. T3 task for executing B3 10 lakh records. T4 task for executing B4 10 lakh records. Okay, fine. But if I go back here, if the 4 tasks are executed by the 4 slaves, if the 4 tasks are executed by the 4 slaves parallelly, if the 4 tasks are executed by the 4 slaves parallelly, suddenly if any one slave goes down, right? Right. Then two things you can observe here. The 10 lakh records are lost. And secondly, the T2 task is failed. Means you can see data lost and that job failed. How Hadoop is able to overcome this kind of issue, right? Okay. Here, two things you can see. If any system goes down, then the 10 lakh records are lost and the T2 task is failed. How Hadoop is able to overcome is there is a concept called replication and fault tolerance in Hadoop. Replication and fault tolerance in Hadoop. Yes. Okay. Okay. So replication and fault tolerance. Replication and fault tolerance. Replication is nothing but duplication. Duplication and fault tolerance. Fault tolerance means if multiple tasks are executed by multiple slaves, if any one slave goes down, then the task of it has to be assigned to any of the other slave. That process is called as fault tolerance. Even duplication means blocks will be duplicated so that even if one system is down, if that block is lost, still the duplicated blocks are available. Right? So in such way, I'll be discussing that replication and duplication in brief. Replication and duplication is in brief, right? So replication, duplication in Hadoop, default number of replicas, replicas. Default number of replicas 3 means 3 times duplications allowed, 3 times replications allowed. For example, f1.txt 192 MB, number of blocks 192 by 64, 192 by 64 means totally how many? 3 blocks. B1, B2, B3, B1, B2, B3. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times, totally 9 blocks. Totally 9 blocks here. This is my master, these are my slaves. S1, S2, S3. 9 blocks are B1 here, B2 here, B3 here. Again B1, B2, B3. Again B3, B1, B2. In this way, 9 blocks are stored across the 3 slaves. 9 blocks are going to be stored across 3 slaves. F1.txt into how many blocks? B1, B2, B3. B1 stored across B1 stored in S1, S2, and S3. B2 also stored in S1, S2, and S3. B3 also in S1, S2, and S3. B1 in S1, S2, S3, B2 in S1, S2, S3, B3 in S1, S2, S3. Now, this is how data storage, data processing. Job to process f1.txt into how many tasks? Number of unique blocks. Here I'm using the word unique here. Always I'm using the word. How many unique blocks here? 9 or 3? 3 blocks or 9 blocks?
3.
3, right? So 3 tasks here. T1, T2, T3. Job to process f1.txt into 3 tasks. T1, T2, T3. T1 for executing B1, T2 for executing B2, T3 for executing B3. Who has to execute this?
S1.
S1. S1 or S2 or S3, any of these 3 can execute because this B1 is present in S1, in S2, in S3, any of these 3. Here also it can execute by S1, S2 or S3. This also can be executed by S1, S2, and S3. Assume for executing T1, S1 only selected by the master. For executing T2, S2 only selected by the master. For T3, S3 only selected. So for T1, S1. For T2, S2. T3, S3. 3 tasks are executing parallelly by the 3 slaves. Suddenly, if this is down, do you see any data loss? Are you seeing any data loss here? Hello?
No.
Still that T2 task is for executing B2. B2 still present in S1 and S3. Still, if S1 also done, if S3 will be accessing those, there won't be any data loss.
So the processing will start again from the beginning, or it will continue from the failure.
When
If T2 fails after 20% of processing,
immediately the task will be assigned.
so the remaining 80%.
Immediately, no. The task will be terminated. Again, it will be assigned to another. Very
Okay.
simple. Okay. Very simple, right? If you are running, for example, on 3 systems, you are downloading 3. For example, you are downloading 3 movies in the 3 systems. First system, 95% done. Third system, 85% done. But in the second system, it's only 4% done. After 5 minutes, S1 and S3 systems both completed the downloading process. But still S2 in the still 7% only. What you will do? Still you will continue that already S1 and S3 their processing is completed. Now they are free, right? Will you allocate to S1 or S3 or you will continue in S2 only?
S2 is not failed, S2 only.
If S2, if I give it, still it will take 5 hours time. If I give to S1 and S3 within 10-15 minutes, it will complete. So I'll allocate to
S1
S2. S2 means I will, okay, then S2, whichever executes first, that I will collect it. Among S2 and the other one, whichever gives the result first, that result will be collected. Okay. So here there is no data loss, there is no task failure. Task will be assigned to any other and that no data loss. Right? This is what fault tolerance and replication. So for on-premises, right? To work with on-premises, so I'll be providing to your Google Drive. I'm going to send some 5 GB of this image, right? And just download it, and I'll be demonstrating about the software in the next session. Next session we'll be starting with the practical part. So before that, I'll be demonstrating, right, about these things, right? First, before I go with the practical part, I'll be briefing you about this Linux commands. Later with the Hadoop commands, we have got some Hadoop commands, right? HDFS commands. And we are going to pull the data. We have got some components like Scoop, SQL, and Hadoop. And some important components of Hadoop like Hive. We have got jobs available on Apache Hive itself if you have got good knowledge. I'll be giving that knowledge on this one NoSQL database like HBase, one streaming component like Kafka, and PySpark. You can just see that course content once again. Check with this. Big data Hadoop, you can see in brief about all these things. MapReduce, Scoop, Yarn, NoSQL, HBase, Hive. Hive in brief, it's a very important tool. PySpark, you can see a lot of course content. Yes, we'll be discussing everything in brief one by one, right? Yes. Deployment, okay. See this groupings and aggregations, various actions and transformations, PySpark SQL data frame, PySpark SQL functions, PySpark built-in functions, PySpark external sources, deployment modes, PySpark application, PySpark streaming concepts, integration with Kafka, PySpark MLA. Apart from this, you can also go with, if doesn't have knowledge on Python, entire the Python course also for an advanced is going to be discussed, and check with that, right? You can see the course content in the chart, everyone, right? So from the next week onwards, we'll be going with this. Next week, the link will be changing, and next week also you'll be having the session at 3 o'clock. But I said after next week it will be at 3, but the next week it will be on 7 to 9, evening 7 o'clock. The timing of your batch will be 7 o'clock actually. But for the next week, it will start at same 2:30 only. It will start at same 2:30 only. But from the upcoming week onwards, once this practicals, everything is started, it will be at 7 o'clock. Fine. So we'll be increasing. Okay, yes.
Saturday can be at 4 p.m. next Saturday. Possible.
No. For 4 p.m., I've got PySpark classes there.
Okay. So next week is same time, 2:30 to
2:30 only. But
Yeah.
the next week it will be, or the next week will be at 7 o'clock.
Okay. 7 o'clock will work, sir, but Saturdays 2:30 is a bit problem.
Only for next week you adjust.
Okay. Okay.
Next, okay, fine. That's why this theory, okay, once we go with the practical, we'll be increasing the time bound, right? Okay. So check with this course content and this.
Sir, this one, Kafka will also be covered, sir.
Yes, Kafka will be covered. Kafka is also go. Let's check it here. Integration with Kafka.
What is this Kafka?
Kafka is a kind of streaming, right? It can capture live streaming data. This Flume and Kafka are there. Flume and Kafka components are capturing live streaming data. Means data which keeps on generating, means it keeps on capturing, it keeps on generating, keeps on capturing. It will dump into this HDFS Hadoop, and it keeps on capturing, keeps on dumping. Every 10 seconds, or if it take every 5 minutes, you can see some events will keep on loading into that. Keeps on capturing, it keeps on loading into the target system. The Kafka is a kind of capturing live streaming data.
Okay, thanks.
Right. Okay, everyone try to enroll before the next week, right? Next week you will get a new link to your mail IDs. Check that new link and check the course content. Everything will be in brief, in depth. Okay, but there are many other students. Once it will be changed to 7 p.m., they'll be attending. As of now, they'll be following the videos. 2:30 they cannot attend because as per the US time zone, 2:30 means midnight, 4 o'clock for them. Fine. So that's the reason we are changing to 7, because of even all the people from US can attend. Meanwhile, they'll be following the videos. Fine. Okay. So I'll stop for now. We'll continue next Saturday, right? Fine.